right, so we've got about 104 manufacturing sites across 31 countries. Uh, this year, May, we actually celebrated 125 years as a company. So wow, we had a nice celebration about that. So then, real simply, you can look at Dow as 3 operating envelopes and 6 global business units. So I actually pulled this out of public information, so this lays it out really cleanly and really clearly. All right, real quick about me. So I make about 32 years with Dow this year. About 25 of that has been in automation. If I look at the last 15 or so years, I've supported anywhere from 50% Dow, 50% acquired assets, all the way up to 90% acquired assets and 10% heritage Dow assets. So that'll be important here in a little bit. My slice of the pie, I've got one of the global business units. I've got the automation responsibilities over the industrial solutions business. Yeah, so when I talk about heritage Dow facilities and acquired facilities, Mike has kind of alluded to Dow's done state-based control. So some of my plants are highly automated. The acquired assets are much less automated. All right, so common challenges today. So what challenges do I face today? So many of my control systems are at end of life or approaching end of life. So I've got an investment opportunity. So how many of y'all, since y'all get to ask us questions, I'm asking you questions. So show of hands, how many of y'all have end of life issues with your systems? All right, I see a couple of hands going up. All right. All right. So the experience curve, the people in my plants, I've got both ends of the cycle, new hires and retires. So I've got people that are new into the business with little experience of our systems and people with a wealth of knowledge of how the plants run that are about to walk out the door. How about y'all? Do y'all have that? All right. About the same number. I've got capital constraints. That's both dollars to go invest as well as the people to go do these projects. I've got environmental, social, and governance reporting things. Now, ESG, that's not a bad thing. Don't think that's bad. It's just all of a sudden I've got new metrics that I've got to roll up to the business and to the state stockholders. And then I've got another criteria for how I fight for capital for investment money in the corporation. Some of my plants, I've got some reliability challenges, especially if you look at the last couple of years, we've kind of been lean on the investments, as you all know why. So I've got reinvestment needs there. And then I've got the expectation, always had the expectation in the automation arena of go create value through automation. So how about y'all? Let me ask it this way. So how do you go create value through automation? What do you look at? Okay, I guess y'all can't answer. Yeah, never mind. Y'all don't have a microphone. I've got that. So I'll go through that. So with Dow, if we think back to the heritage Dow facilities, when I've been told to go create value through automation, there were expectations of what that value creation meant to go do. So now this is where I really come into where I've supported assets that were predominantly acquired assets and not the heritage Dow assets. And I struggled on how do I satisfy my leaders and go create value in automation. I was facing challenges. So I came up with this a couple of years ago and said, hey, here's a way to show what my troubles are, what my struggles are. At the base, I need a strong foundation to build automation and sustainable value. Reliable instrumentation, sound-based logic configuration, and sustainable control system infrastructure. So that weighs into my control systems are approaching end of life right now. So I'm challenged on there. In the acquired assets, sound logic configuration, boy, there's IP in some of those control systems we want to lose and destroy quickly. A lot of configurations where this is how the last person did it, or this is how I did it last month down the road at another person. Some of the configuration, it's actually driving the plant to be unstable. With a strong foundation to build on, said I've got some pillars that I need to have. Now I put this together, just threw this in for this presentation, so there are some points here that aren't pertinent, but standards and conventions around logic configuration so that there is consistent control system configuration. I've had people, that whenever there's some type of a process issue, it's always the control system's fault. So we always call a control engineer, come fix your problem. Nobody wanted to look into the control system because the configuration, you can't make sense of it. And a problem that you solved today, you may see the same thing tomorrow or the next week, but it's a totally different problem because of the way the system's configured. And I'm still told to go create value. So Dow had the expectation of there's three ways to create value. And Dow actually learned this a long time ago. So you heard we talk about state-based control. So Dow actually learned a long time ago that we could capture manufacturing operating discipline in the control system. We could configure repeatable logic configurations in a library to leverage across the globe to roll out changes very quickly. Real simply put, control system was driving the transition from shutdown to steady state operation, from steady state operation back to shutdown mode when required, and then to manage any process upsets or perturbations. So we always wanted to keep the plant running. If you're interested, it's actually a pretty good read. There's 6 articles in Control magazine that kind of lays out why Dow did this and what the expectation was. Next is multivariable control. So, basic control system, single loop control, we can optimize and drive against constraints. Now Dow also chooses one vendor to go do multivariable control. So again, we've got standard configuration techniques and we can globally support and troubleshoot any problems there. And then closed loop model-based optimization. So our DMC, we're looking at a plant or unit operation optimization. Our model-based control looks across the entire plant or across multiple plants to optimize performance there. So you may be saying, so what does this have to do with autonomous operation? So here's another descriptor of levels of autonomy from 0 up to 5, from manual, fully manual, to totally independent of operators. So state-based control, it gets us between 2.5 and 3, a level 3 autonomy, because the control system is driving all of the operating procedures. Model-based multivariable control will get us a little 3, 3.5, and then building on top of that, our closed loop model-based optimization. All right, so let's talk a little bit about state-based control, because I get a lot of questions and discussions around, well, state-based control, that's a single button to start the plant up and you walk away from it. I'll tell you that's not what state-based control is, not how I see state-based control. So let's compare it to loop-based control, conventional loop-based control, where the control system is configured for steady state run at max rates. You build the strategy based on what your P&ID show. So how does an operator get the plant running? Well, he's got procedures that he's reading through. Then I've seen where procedures are kind of good suggestions and don't always tell you what to do, so you rely on operator knowledge and memory, the tribal knowledge. What you find is if you learn something in a process that you need to improve because you had a problem, that's very slow to propagate or spread across the control organization. And then the control system, it's conservative. So it's gonna shut you down when it starts seeing something going awry, as opposed to reducing operations or reducing rates to maintain the plant running. So it's a bunch of words. So what's that look like graphic or in a picture? So you've got a board operator who's sitting there. You got the plant out there with all these signals coming in, and he's got his supply of procedures off to the side that he's looking at. So it's up to the board operator to look at the data points coming in, put it in context with his procedures, and determine, so what do I need to do next? And then what he's doing next is he's talking with people in the field to say, open this, do that, start this pump, swap this valve around, or doing some work on the control board. All right, so I didn't do all my homework. I don't remember what year this was put out, but ARC had queried industry and said that we lose about $20 billion, or 5% of annual production due to unscheduled downtime. And of that, 42% was from operator mistake, or operator error. So too much data coming in, looking at it in the wrong context, making the wrong decision to go do. I'm not faulting the operator there, it's just fat finger mistake, wrong idea of what he needed to do. So what happens when an operator makes a mistake? Sometimes it's nothing. Sometimes we never even know it because they quickly recover and it's transparent. Sometimes it's a long shift for the operators, or the next shift gets upset. The next shift gets upset because, well, crap, I've got to clean up this product. But sometimes it ends in a really, really bad day or bad week or bad month for the operator. And we've all seen this too many times. So think back to the comment about a lot of my staff is new hires and retirees. The board operator in a manually operated plant depends on procedure and tribal knowledge and memory of how to run the plant. As we're losing this knowledge, we're setting our operations staff up for greater chance to make that fat finger mistake and have a really bad day. So just real quick, so state-based control, we capture the operating discipline, the procedures, the tribal knowledge, and the control system configuration, so that the control system will always make the best and right decision regardless of what's going on. We can test it, we can train on it, and we can quickly leverage it out across the organization. In addition to those benefits, improved board operator span of control. So now a board operator, he's not running a single unit operation at a time from procedure. He's got a broader span to look across, how do I optimize how my entire plant's running? How is the entire health of the plant look? Then this is worded incorrectly, reduce both inside and outside operator. It reduces the need to replace the retirees as some of them go out. You let the control system do more and more as opposed to having an operator to do everything. So what's my path forward on this? So I've still got a lot of acquired assets. So I have a lot of assets that do not have state-based control. As we're renewing our control systems, part of that renewal is improving the level of automation. And I've got asset utilization data to demonstrate to the business why it's valuable just from a cost generation standpoint. In addition to the operating discipline that we talked about and the safety factors, I can tie dollar values to it. A recent example of one of these was we retrofit a plant. We did the front half of the reactor area. That was where the AU data said our greatest losses were. So we generated 1.5% AC improvement. The plant was sold out, so it paid for itself very quickly. From an alarm rate, we reduced alarms by 50%, so the operators got less information coming in demanding attention, and we reduced operator touches by 60% to run the plant. Fewer touches, less of a chance to make a mistake, less of a chance to make a mistake, you don't have a really bad day. Multivariable control. So I am building on proven multivariable control benefits. I have one plant that we've saved about $1 million a year in steam with multivariable control. Not only is it $1 million savings, we're firing fuel gas to generate that steam, so I get my ES&G credit there. And yes, I'm looking for every little bit, regardless of how small it is, to roll it up because it matters. From a yield improvement, at this one facility, it's about $500,000 a year in yield improvement. So same raw materials in, a little bit more valuable product out the back end. So we're talking autonomy and manufacturing 4.0. So that's, everyone's doing something with manufacturing 4.0. So we are as well. We've got broad business as well as corporate-based activities. Now, one thing I used to be kind of embarrassed to say this, but one of our key first steps in our manufacturing 4.0 journey, well, let's get all of this discrete data into a common place so it's accessible. I've heard from a couple of the talks here this week, a lot of people are in similar conditions, so I don't feel so bad saying that. With the data there, though, why are we putting it there? We want to put the right data in front of the right person at the right time to improve decision making. So we've got 2 tracks in our data collection. We have one track that we're looking at for plant monitoring. So that's near real-time data that we can use from people off-site, like working home during COVID, to help look at the plant and troubleshoot any issues there or identify areas that are going wrong before we have some type of an event. And then we've got slower data roll-up for reporting, be it EH&S reporting, asset utilization reporting, loss reporting, and all of that stuff. Now, we do have some work on artificial intelligence going on. Nothing in machine learning yet, but artificial intelligence. So one of the nice things in my position is I get to work with some really, really smart people. And one of the things that we've realized is everybody's got a different opinion of artificial intelligence. So what are we doing with artificial intelligence? Well, it's actually analytical information, refining analytical information to help drive decisions there. So we've got use on that. And then talk about the procedures, computer-augmented procedures. We cannot afford to go automate everything in a plant. If I look at some of the older plants I've got, I don't have room to go put an actuator on a valve to automate that, but it's important to have it automated. In some cases, we've got routine events that we're not going to be able to automate our way out of, be it a strainer or a filter change out, filter replacement. There's always going to be some type of manual event there. And when we look at the manual event, especially filter pots, strainers, what are you doing? You're opening a line. If we're just flowing room temperature water, opening that line's not that big of a deal. If you're flowing a hot or toxic material through there, and you don't have any type of interlocking capability or cross checks before that vessel's opened up, that won't go too well. All right, so in summary, state-based control, it's a proven form of autonomous operation. It effectively reduces operator intervention and the chance for error in a process. It can return a positive investment. It's available on most every control system vendor today, and I think it provides you a very sustainable foundation to go pursue all of this manufacturing and manufacturing 4.0 and higher levels of autonomy that we're talking about here this week. So thank you.